All right.
Hello and welcome. We'll go ahead and get started. I'm Vincent.
And I'm Andy. And we're in the Linux team within the Azure Core organization. And this is perhaps one of the most ambitious talks that I've ever given, because we're trying to cover everything happening in Linux in just 45 minutes. So we will only be able to cover a few highlights, and it will be quite high speed. But we've included links throughout the presentation, so you can download it afterwards and go click them and follow up and get more details. OK, first, show of hands. Who's heard this expression, Microsoft loves Linux? OK, good. The marketing team's doing their job. So it's no secret that within Microsoft, the love of Linux has been a bit of a journey. It's taken a while. It's full 15 years since we actually started contributing to the Linux kernel to enable support of Linux in Hyper-V. And starting in 2012, we launched support in Azure for Linux and gradually added support for more and more endorsed distros. And remember, Azure started as a Windows cloud. So it's quite impressive that within just 7 years, more than half of the workloads running in Azure were actually Linux. And even more exciting, in 2021, we actually shared that Microsoft has been building its own Linux distribution. Initially, that's just for our own internal use, and we still use it very much internally. It's the standard Linux. But at Build last year, we actually announced the availability of Azure Linux as the container host OS for Azure Kubernetes service. So third-party users, customers are using that as well. We also recently announced Azure Boost, our Linux-based offload processor that's really the core of Azure's next generation infrastructure architecture. So that enables the performance required for AI, high-performance computing, and other demanding workloads. So we might have been a little bit late to the game, but we're all in on Linux now. And today, I can actually share fully 65% of our customers' workloads in Azure are running on Linux. And Linux remains the fastest growing platform in Azure. So it's super important to us. But it's not just to our customers. For Azure ourselves, we have embraced Linux for our own services. Some of your favorite and most used Microsoft services today are powered by Linux underneath the covers. Things like HD Insight, Defender, Postgres, EKS, Office, DNS servers, a whole bunch of capabilities that are delivered in Azure. And in fact, most of the modern workloads and the infrastructure that's being built is actually running on Linux. So it's super important across all of Microsoft. And of course, crucially, all the latest innovations that you see in AI are being built on Linux today. So OpenAI trains its models on one of the largest supercomputers in the world running Linux in Azure. So when we say, and you may have heard this phrase, Azure is the world's AI supercomputer, what we're implicitly saying also is that Azure is the world's best platform for Linux. And that's quite a claim, especially considering that long history we talked about, right? So how do we ensure that? Well, what we do is basically across the entire engineering organization, we have dozens of engineering teams that are focused specifically on Linux. From the kernel engineering team to a quality team, to continuously improving our own and our customers' security posture in Azure, to cloud native and more. And today, we're going to share a bit more about what some of these teams are doing and how deeply engaged they are with the broader Linux open source community to deliver the best possible experience to our users while raising the bar for the industry as a whole. So let's talk about the variety of Linux distributions in Azure and how users approach those. Really, there are two kinds of users, broadly speaking, that we see. So some, like Anna here, right, who says she has a preferred distribution. She just wants to be able to run that distro of her choice. She knows what she's running and already maybe on-prem, and therefore wants to run the same thing in cloud. And there are those who don't have a strong preference, particularly, like Bob, right, who just wants to come to Azure and just says, give me whatever works best. But they both want to know, how do I find, how do I procure, how do I deploy those images? And they want to know that Microsoft has got their back when it comes to supporting the technology and working with the vendors and the communities that publish those images to ensure quality, security, and reliability. And the first point to make for someone like Anna, who has a distro that they want to run already, is that our official support policy, and you can go look this up, is really we welcome all flavors of Linux. If you can bring it into Azure, you can create an image, you run it, we will work with you to make it work. And we work across the industry to ensure that just about every major distro and most of the smaller ones can run in Azure, and to ensure a wide selection of great images in Azure Marketplace. And Marketplace is the starting point if you've got a specific distro that you're looking for. It houses thousands of offers from publishers across the industry, including base OS images and applications. So just to show you quickly what that looks like, if you go into Azure Marketplace, you can go into search here. So if I want to search all apps for Ubuntu, that brings me up an Ubuntu image. Or if I want to search for RHEL, it'll bring me some official RHEL images. So that's the place to go to find the image that you're looking for. You can even use a base image from Marketplace, customize it using Azure Image Builder, and store that image in your own private image gallery. And that's actually what a lot of users do for internal distribution of images based on Marketplace offerings. Now for Bob, who doesn't have a specific distro he's looking for, he's probably going to start out by going to look at what are the endorsed distributions in Azure. And we currently have 7 endorsed Linux distros, including Alma Linux, which was just added last month, so that's the newest here. And another recent change, if you're eagle-eyed and keep an eye on the endorsed distros page, you'll notice a missing item here, which is CentOS. Now, CentOS has been on the distro list for a long time, but that went end of life in the middle of this year, so we're not going to endorse something which is out of support. But for those impacted by that, and there are still a lot of people running CentOS in Azure, we encourage them to move to a supported model, and there is a page in the docs which provides guidance on the migrations options there. So actually, if you look at the endorsed distros list here, so there's a link here to this page. You can see if you scroll down, you get to see that list of images, and there's a whole load of more information in terms of the kind of support you get and update image cadence and all of that stuff. So that's a great reference. So I talked about endorsed distros. You might think it's kind of it's obvious what we mean by endorsed, but it's worth kind of digging into that a little bit. What we actually mean by this is 4 things. So for us to put distros onto that list, first of all, there's actually a contractual agreement we have with the provider of the distro that ensures certain things that we want to see, such as deprecation commitments and things like this. Secondly, we have a close engineering relationship, so we actually have a forum where our engineering team works together with the publisher's engineering team, so we can exchange bugs, issues, talk about enhancements, talk about upcoming hardware that's being introduced into Azure, and make sure that there can be support for that in the distro, all of those kind of things. And we've got a path for escalating issues. Next, we do want to see some demand for it, so there needs to be strong market demand. And finally, that the publisher's maintaining the update infrastructure, that we want to see the publisher actually publishing updates on a regular basis, fixing vulnerabilities and things like that, but that they actually maintain that infrastructure in Azure so that users get the best possible experience when pulling updates. The last thing I wanted to mention on the topic of distros is at Ignite last year, for those who are here or not here in Seattle, we announced the Community Image Gallery. So this is something that allows publishers to take images and publish them without having to go through the full marketplace vendor certification process. It's much more appropriate for kind of community open source distros, and we've seen a number of those distros embrace it as a way to easily share their images. And in particular, we've been working hand in hand with a lot of those communities that have come to us, asked for help getting images published. And especially with Fedora, it's been quite a long journey. You might have thought Fedora would have been in Azure sooner, but it actually took the Community Image Gallery and working with them to get that added. And we've also enabled, not just in the image gallery, but also in Fedora Cloud, so that users can create a Fedora-based VM directly from the Fedora web page. I'll just show you quickly what that looks like. So if you go onto Fedora and follow the Fedora Cloud link, on this page here, you can access all the images, but they actually have a really nice little shortcut if you want to try something out. So now this is new that it says Azure there. I can click that, and it actually brings up all my regions here, and I can click that, and it'll take me to the Azure portal and create a VM. So that's a great example of how our upstream Linux engineering team is engaging with the community, really to make deployment on Azure as simple as possible and as seamless for customers. So one customer who's embraced Azure's support for Linux is Fujitsu. And at this point, I'd like to invite Chris Quinn to the stage. He's the global owner for cloud transformation at Fujitsu to share his team's experiences. Chris, welcome.
Okay. Thank you, Andrew. Thank you. And thank you very much for the opportunity to speak with you all today. It's wonderful to be here. And as a strategic partner of Microsoft, we're very, very closely working together on all of our technologies, and Linux is one of those. So I really appreciate the team's time to bring us to the stage. Before we get started, in the keynote yesterday, there was a contest that was being held by the host to see who had traveled the farthest to be at Ignite this week. I'd like to introduce a colleague of mine, 𝗬𝗲𝗂𝗏. 𝗬𝗲𝗏-san, please stand up. So please welcome 𝗬𝗲𝗏-san. He traveled all the way from Tokyo, Japan, to be here from our home office. Thank you, Carl. Thank you very much. Okay, a few words about Fujitsu. We are agile. We are innovative. We are a global IT, cloud application services team. We support integration and consulting for all of our customers. Our principal industries, primarily in the North America, is manufacturing, retail, and the public sector. And a few years ago, we embarked on a journey to begin a shift to the cloud. And that's where our global team and myself come in to drive that adoption. So I'm going to tell you more about it today. First, let me explain the relationship that we have with Microsoft, why we're here. We have global and regional representation from a fantastic team that supports us at all levels. Microsoft is providing platform design considerations, and as our team begins to adopt cloud, and we begin to move workloads, distros, from on-premise to cloud, we understand that it requires new skills and new learning to support that ongoing. That, of course, is our long-term goal. And Microsoft is providing us with continuous upskilling support to drive that process. Our success is supported directly by Microsoft. More specific to Linux, we're receiving engineering support, such as long-term license support for Red Hat, enhanced EUS, design capabilities around IaaS, PaaS, and container services, very critical to us at this new juncture, network topology, and most importantly for our entire program is Defender for Cloud. So our collaboration with Microsoft is driving our transformation. Just a quick graphic on our landscape just to understand how important this is to us. Red Hat is our primary platform. It's in use for high demand and use for our mission-critical systems. We also have some instances of Ubuntu and SUSE as well. But as you can see here, almost half of our estate is Linux. So it's very important that we're continuing our collaboration with Microsoft. I mentioned program a few minutes ago. What is our program? Our program is what we call DXP Cloud. This is a complete infrastructure services transformation, and it is global. Of course, based on the Azure platform. We call this 𝗦𝗲𝗀𝗀𝗀𝗏. It provides us with flexibility for traditional IaaS, PaaS, as well as container services. Some features include modern, robust functionality, an Azure landing zone architecture built from the ground up, which includes enhanced security, which is the most important thing to us. Our general scope is primarily all global operations, both for our Fujitsu and Fujitsu Group companies, some of you probably heard of. And we're now just starting to look to see what AI can do for us. Obviously, a very critical topic this week. We want to see how we can help improve our operations, streamline and improve our user experience, and also development cycles. Just a quick word on activity to date. Really, the numbers aren't so important here as much as the plus signs that we've added to the end. We're about halfway through our journey, but we're constantly accelerating our adoption to the cloud. Over 400 subscriptions, 2,000 VMs, around 400 PaaS instances, and a few words about containers. This is a critical point for us and something new for Fujitsu, particularly in Americas. We asked Microsoft for help. How do we deploy containers? What's the best process to use? How do we make that happen? And Microsoft supported us with resources, training, upskilling, and helped us develop basically a center of excellence within the office in Dallas, where I'm from. And we're now self-sufficient in deploying containers. And our team in Dallas has now become the sort of the global standard in how we want to deploy containers. And Microsoft's been critical in supporting us in that endeavor. Just a few words about deployment fundamentals. This is some problems, one of the problems that we had and that we've seen in the past. When we're deploying workloads manually, we needed to be able to ensure that security and governance is deployed automatically. However, if we're missing settings and diagnostics in a manual process, not only do you increase the risk of missing something important, but it also kind of stretches out that lead time. And that can be measured in weeks, as many of you probably have already seen. With using Azure functionality and Microsoft's help, we've been able to help to minimize that impact and to minimize the impact of risk of missing something, automating through DevOps, which includes Defender for Cloud and Azure Policy Enforcement and integration. We've now shortened our deployment time to minutes. One more quick word on specific about Red Hat. We've reduced the burdens. We want to reduce the burden of license and OS patch application management. We have because within a large server estate, this can be a time-consuming and manual process. Tracking deployed licenses, maintaining patching status and levels, as well as applying license renewals on individual servers across the estate. Like I said, half our estate is Linux. This is very important. So now working with the Azure team and understanding how we can automate certain things, we've been able to aggregate that process and centralize management through the Azure Update Manager. So thank you very much for your attention today. I'm going to turn it over to Vince.
Thank you.
Okay, thank you.
Yep. So yeah, thanks, Chris. And it is inspiring for us on the product side to see how the work that we're doing to make Azure a great place to run Linux actually comes together for a successful deployment experience. Chris touched on the topic of security, and I want to dig a bit more into that. So we live in an environment of increasing attacks. Things like the 𝗦𝗲𝗀𝗀𝗀𝗀𝗀 attack, where an attacker had literally spent years building the trust of the developer community, only to be thwarted by a vigilant Microsoft security researcher, has opened everybody's eyes to the scale and the scope of the kind of threats that are out there, and it's put everyone on alert. So you've probably seen this slide already, and that's for good reason, not here at this talk, but at the conference. Microsoft, we take our responsibility to help customers deploy securely very seriously. Our Secure Future initiative focuses primarily on the security of Azure infrastructure and services, but also with working with the community around increasing the industry's security posture. Of course, we offer a portfolio of enterprise-grade security products like Microsoft Defender for Cloud and Sentinel, but the core of Azure's platform offers a number of security features that we're continually enhancing for our customers' environments to make sure they're secure, as well as some of our own. Some of these are behind the scenes, and some of these are capabilities that we expose to you. So the first thing is making sure that the images that are made available in the marketplace are a secure starting spot. That starts with the validation of the publisher, like Andy had talked about, and then it goes on to the certification of the images themselves. Over the last couple of years, we've significantly expanded the range of tests that are applied on when we ingest these images. So now that includes a full vulnerability scan, and we continuously are applying after the image is pushed as well. So that next level for the images is how do you ensure the operating system that you're booting is itself secure and unmodified? We have Azure Trusted Launch. It ensures that the integrity of the OS image is both at boot time and then with guest attestation agent on an ongoing basis. So I'm pleased to share that by the end of the year that all of the endorsed distros that we mentioned will all be supported with Azure Trusted Launch. So then, again, building on Trusted Launch, the next level of protection is to ensure that the data in use, that is like the environment that the guest VM is running, is actually encrypted so that no one outside the guest, including the cloud provider, can access its contents. This requires hardware support. We have partnered with Intel and AMD to enable this in Azure. And so last month we announced OpenHCL. It's a paravisor that enables even older distros to run in this confidential mode that was developed by Microsoft, and now we've made it available open source. But continuing, it's not just about VMs. So confidential computing needs to support containers also as the modern unit of compute. At Ignite last year, we announced confidential container support for AKS. Today, following a close collaboration between Microsoft and Red Hat, we're excited to be announcing the public preview of confidential containers for Azure Red Hat OpenShift, the ARO. This is leveraging AMD's SEV SNP technology to protect the containerized workloads through hardware-level encryption and isolation. This is provided at no additional cost besides the standard compute charges. Also recently announced in September is the ability to extend that confidential compute boundary beyond just the CPU and memory, but into the GPU and the PCI Express bus that connects those, so that you can have a fully confidential environment, GPU-based AI workloads. The initial launch of this capability is on Ubuntu 22.04, following a close collaboration with the Ubuntu team at Canonical. These are both a couple of great examples to show the ability not just to innovate across hardware and operating systems, but the boundary that's built on the foundation with close relationships with upstreams and communities and our vendor partners. So, secure boot ensures the integrity of the operating system. But what about binaries that you run even on top of that? So this is where integrated policy enforcement comes in, IPE. With IPE, the Linux kernel is actually checking that every binary that is running is signed by an approved source. While this might not be appropriate for all general purpose situations, it is for appliances that you know exactly how the appliance that you want to run. It mitigates low effort and high value attacks like linker hijacking, binary rewriting, and malicious binary execution. This was developed by our Linux kernel team, and it's been now merged into the Linux kernel upstream as of August. To be clear, this is not a service that we're offering. This is an example of this is a Linux capability that we are making use of internally and that we're building on. But it's mostly an example of the kind of security pushing forward the posture, even contributing it straight up upstream into the broader community. So here is a service, though. We have had the Azure security baseline for Linux so that you can audit the conformance to a subset, about 2/3 of the CIS standards. We're announcing that this is an enhanced audit experience now with fully aligned to CIS. The big deal is that we're also enabling auto remediation. This is built on source code that Azure has open sourced, and it enables collaboration both across the company and with the Linux community. We're going to take a quick look at that. Oh, this one's already recorded. So here we have our Azure policy and our policy in the Azure portal. So we have one just for the Ignite demo that we're running. Note, this is all a preview. The final user experience might be different. So underneath the configuration management, you'll see that we actually have 51 non-compliant items out of 168. And you can also see the CIS benchmarks. This is flying. We said it's a lot of information to get through. So we're actually going to go into the parameters and change to deploy if not exists. That means that if it's not correct, it'll actually change it. Be sure to check the box if you have existing resources that you want it to apply to. By default, this feature is only going to work for like current and future. So you check the box to apply to existing. This is a demo, so it's sped up. We recorded this. So once the remediation is already run through, you'll see that we're only left with about 3 of those 51 items. And those are things that you like manually have to remediate. Can't be auto done. So if that is something that is interesting to you, here's the QR code for the preview link. Also, the slides will be available later, so you don't feel like this is the only time you're going to get to see this. All right, quality and reliability.
Thanks, Vincent. So I love the auto-remediation capability. I think it's going to be a game changer for a lot of users. And because security is our top priority, it's our users' top priority, but after security, the second most important topic for our customers is quality and reliability of running Linux workloads in Azure. And just to give you some idea of the combinatorial complexity involved in ensuring quality across all of the different publishers, endorsed distros, packages, extensions, and features that we support, across all the different types and sizes of VMs we offer in Azure. This diagram kind of gives you quite a good picture of that, I think. And it also highlights it's not just what's running in the guest, it's also about ensuring the quality of the platform underneath the guest as well. And making this all add up is the job of our Linux platform quality team. And to address this multi-level complexity, because it really is, it does have multiple levels to it, a lot of complexity, we need a multi-level approach. And that starts with the quality of the kernel itself. So we work closely with the upstream kernel community. We sponsor the kernel CI project. We're continuously running tests on the kernel. So if anything looks like it might break in Azure, we identify that really quickly and make sure that it doesn't get out into the wild. We also have invested in this testing framework we call 𝗲𝗲𝗀𝗃𝗃, Linux Integrated Services Automation. And that includes hundreds of tests across a broad range of different areas to validate that a specific image is working well in Azure. And we also use it ourselves for testing extensions and other things, parts of the Linux ecosystem. And we actually made this open source, and we encourage everyone in the community to use it. You can use this in your own environment and extend it, write your own tests, and use it as a platform. Now, remember how Vincent mentioned that we test images for vulnerabilities on ingestion into Marketplace? So that tooling we call 𝗦𝗲𝘀𝗀𝗃, and 𝗲𝗲𝗀 is now included in that test process as well. So as part of any image from any publisher going into Marketplace, it runs through this full set of 𝗲𝗲𝗀 tests before it even gets published. Lastly, we've recently started to actually host a service so that publishers can easily run the full 𝗲𝗲𝗀 test suite themselves before submitting, so that they know what's going to pass and fail before it even gets into our pipeline. And we call that service Azure Image Test Service for Linux, or AITL. It's currently in private preview with select Linux distro partners. Now, one common source of outages is when you get a bad patch applied, because we're continuously updating operating systems because of all these vulnerabilities. And anytime you make an update or a change, there's risk involved in that. And distributions are complex, thousands of packages typically, and maintainers make mistakes, or these things happen. And that's why we have safe deployment practices where we roll out across the fleet progressively and we stop if we hit a problem. We do that region by region. And the problem here, though, is if an error is encountered, you can actually end up with different machines across your fleet running different versions, and potentially multiple versions depending on at what point updates are applied. And realizing this, and to be honest, we were licking some of our own wounds with this. We actually worked closely with the community to implement a better approach. So in particular, working closely with our colleagues at Canonical and the Ubuntu community, we added support into the APT package manager to be able to deploy from a specific date, not just to say, give me the latest version of this, but be able to say, give me the version on the 16th of August 2024 at 10 a.m. And so you get that specific version. And that also leverages the Ubuntu Snapshot service and the Azure Guest Patching service, really to ensure that you can know that your fleet has a consistent set of packages across the entire operating system at a particular given point in time. So this is a game changer for stability for us for Ubuntu, and we're looking really to work with other distributions to try and enable this kind of capability in other distros as well. But not everything we tackle is the same scale and scope as all of that quality work, which is huge, right? Sometimes it's just about adding a small capability or a nifty little tool. So let's look at some of those. A while back, we added support for RSA format SSH key creation and management via the Azure portal and CLI. But for some time, we've heard from users that they also wanted the ability to use this newer ED25519 key format. And I'm pleased to say that this capability was made generally available last month. So that's been very popular with a lot of people. And we're going to be looking at, if there are other key formats. The way we've implemented this actually is much more flexible than the previous one. So adding new key formats should be easier for us in future. Another area we've had feedback is that users wanted to have deterministic control over the numbering of the NVMe devices. Again, kind of very specific problem point, but we go and look at that issue that we're hearing from users and work out how we're going to go fix it. And in this case, open source first, right? If we can build this in an open source tool, we'll publish it as an open source tool. But we actually realized this is probably not the last case that we're ever going to hit of needing to write some kind of utility. And so we created a repo called Azure VM Utils. So while this NVMe ID utility is the first and only one in there today, watch that space, because we may well put other things in there as we hit other specific point problems and create a specific utility for it, which is very much kind of the Linux ethos. The last interesting open source tool that we've published that I want to talk about in this section is it's actually a reference implementation of a provisioning agent. So just to explain this, most distros today use a package called Cloud Init for system provisioning. But this new Azure Init project actually performs the same job for the most basic fundamental provisioning tasks that have to happen to get a distro up and running in Azure. So in some cases, a very lightweight distro may not want a full Cloud Init, which brings in a full Python environment. So maybe they'll use this as is, or it could just be used as a reference to see how do you interact with the Azure control plane to extract the data that you need to provision a VM. So that's out there in open source as well. Now, whether we're talking about observability tools, security, performance analysis, networking, a whole bunch of things, or even whatever you might want to develop, there's a whole lot of use cases where you're wanting to dig deep into the system, and inevitably we hit that challenge of how do you get your code to run at the lowest level in the kernel. And traditionally, this meant building kernel modules. That's fraught with compatibility, stability, security issues, right? eBPF is the latest technology which enables you to do this without using kernel modules. Allows you to run code. It's a bytecode format, and it runs in a protected virtual machine in the kernel, so it's safe, and it can interface to all of the key kernel functions that it needs to. And Brendan Gregg at Netflix described it really succinctly. Just think of it like this. It does to Linux what JavaScript does to HTML, but sort of. So not every analogy is perfect. And at Microsoft, we've actually been using eBPF extensively. So we have an open source project called Inspector Gadget, which is kind of a foundational project here, and which we've donated into the Cloud Native Computing Foundation. And this is used by a number of internal Microsoft teams for applications from security. So it's used in Microsoft Defender for Cloud, to network observability. So it's actually used in the Retina project, which is part of advanced container networking services in AKS. And just troubleshooting and diagnostics for Kubernetes and Linux VM environments. And it's one of the most popular plugins also for the VS Code extension. As you can see, the list of gadgets available already covers a really wide range of use cases, from suggesting security policies based on observed behavior to troubleshooting networking or performance issues. So let's just take a quick look at a couple of gadgets in action, just so you can see how easy this is to use. So we're going to run this gadget called top TCP, which is just going to look at the pods running within a cluster based on the activity that they're generating over TCP. In this case, we're looking specifically at receive, so we're going to sort by the received bytes and look at a maximum of 5 entries. So when we enter this command, it'll come up, and we can see here are our current top 5 pods, and they'll change around as the network activity changes. So that's super useful just for seeing what's happening quickly within your cluster. Next example is more of a troubleshooting scenario. I've got some I/O latency problems on a Linux host. So we have a gadget called profile block I/O. In this case, we could output as text like we did last time, but we've actually hooked this up to Prometheus, so you can capture the output. So when we execute it and then go to the Prometheus UI, we'll see it's actually going to show us a graphical chart of the output. It'll take a little while to listen and find the block I/O latency, but after a couple of seconds, you can see the chart there, and you can start to dig into what's happening and where those bottlenecks are. At this point, I'd like to hand over to Vincent to tell us a little bit more about where we see Linux headed from an architectural perspective.
Yeah, super. Because after all, not just being involved, but helping shape, like we mentioned with the security started to begin with. The interesting thing is that the basic concept of mainstream Linux distros has not changed for a couple of decades. I mean, there's been some interesting experiments, but for the most part, when we think of a traditional base distribution, it contains a kernel, it contains an init process, it includes some base set of packages, and then it has a package manager so that you can deploy additional packages. So while there is infrastructure as code, tools that allow you, the model is still basically an interactive install that's customizable by the user at any point in the machine's life. This model has served us well, but it's got several disadvantages. When you start to manage machines at scale, as you do in the cloud, and across a large fleet, you start to see packages updating inconsistently, configuration drift, especially from those times when a user SSHs in just this one time to fix something. On a problem on a node, the security risk on the OS not being locked down, generally much larger sets of, they also generally end up having much larger sets of packages installed on the machines than they're necessary. So first, I'm going to talk about one such example of a purpose-built Linux distro. Chrome OS, Chromebooks, demonstrated a different approach. They had an immutable OS partition that literally could not be changed. It was an atomic, like a image-based atomic updates with automatic rollback. So if it rolled out a new update that failed for whatever reason and it had a list of checks on boot, it would roll back. The result was solid and reliable, although limited desktop environment. Later comes along Core OS in around 2014. They adopted literally the Google Chrome OS, but made it for server hosting for containers. This model became adopted across the industry as a special purpose scenario. It is not well adapted for general purpose workloads. Again, it's special purpose. Over recent years, the industry has been looking at how to combine the reliability of containers in the OS with the flexibility of general purpose Linux distros. So even very recently with projects like coming out of Systemd and the BOOTC project, we predict to see this approach kind of become for a common wider range of applications. So the shaping and evolution, it cannot be done in isolation. It requires hands-on and with upstream projects, the whole ecosystem. Microsoft's there with co-founding the user space API working group. This has got partners from all kinds of major Linux distributions, as well as leading projects like having the lead maintainership on projects like Systemd, and lots of interesting developments coming out of that group. Co-chair of the Cloud Native Compute Foundation Special Purposes Runtime Working Group, and even recently with the Flatcar Container Linux, which is an evolution of that Core OS, immutable OS, is now been donated to the Cloud Native Compute Foundation. So this is going to be directly involved in like cluster API and other like system extension capabilities. So in wrapping up.
Yeah, thanks, Vincent. So hopefully that's given you a little bit of a taste of what we're doing and where we're headed. And we started out talking about the Microsoft loves Linux journey, but hopefully the takeaway from today is that Microsoft doesn't just love Linux, we live Linux. It's the majority OS in Azure. It underpins much of our infrastructure of services, and we have dozens of teams across the company specifically focused on enhancing quality, security, reliability, usability of Linux. But the key thing and the key takeaway really from this talk, I think, is that we don't do this work in a vacuum. Right? The open source community has a really strong cross-vendor collaborative ethos. And that's something that we live and breathe across all of these teams that are working on Linux within Microsoft. And we think working with the community, we're driving the whole industry forward together. So that was a very fast 30,000-foot view in a very fast airplane of a whole lot of things happening in Linux. As you can see, it is moving fast, and to keep up with the pace of change, I recommend you follow our Linux and open source blog, which includes a quarterly update authored by Henry, sitting here, our wonderful product marketing manager for Linux, of everything that's happening in Linux on Azure. So that wraps it up for this talk. We've got a couple of minutes if there are any questions. You don't think they'll fit into 2 minutes? Okay, we'll be around afterwards if anyone wants to go into deeper.
Yeah.
Yeah. Do you want to come up and speak to the microphone?
Are there any efforts going on with integration?
Yeah, absolutely. So a lot of what we're talking about, and even the workloads that we see, are talking about the VM workloads behind the scenes. Personally, as not just an employee, but as a Linux enthusiast myself, we have Linux on the desktop. So my primary machine is an Ubuntu machine with Intune, and it's got the Intra plumbing for like device identity and brokering. New stuff is happening there all the time, even like this week, talking about some of the pass-through from on Windows side with WSL through Intra, so like 𝗦𝗲𝗀𝗀𝗃𝗃 CLI works. This same kind of thing is rolling out even for Linux. So with that identity broker, it should pass through even for apps like the 𝗦𝗲𝗀𝗀𝗃 when you're on the Linux desktop. There are some headless use cases even for servers that are fully attached. That's still all in the works. What else there? Oh, yeah, and there's a few different Linux desktop issues there. Not issues, advancements. But it plumbs through with Intra. So lots happening, and it's very, like, I'm glad that it's so usable because I use it every day.
We have a lot of legacy use cases where users are running desktop sessions on workstation VMs in Azure, and they're still consuming POSIX attributes from on-prem AD, and we really like to do that.
Okay, so for not being on the microphone, he said they're working with loads of legacy passing through from like AD and virtual desktops, and they want to move all that to Intra. So yeah, follow up with me. There's some interesting use cases, but it is coming a long way, especially if you're working with Linux on the desktop, which here at a Microsoft conference talking about Linux on the desktop, but it's actually a pretty good experience specifically on the Linux on the desktop. Yes, sir.
Yeah.
Yeah, please.
We didn't mention much about VSL, Windows Subsystem Linux. We want to enable it for our developers, but currently we cannot do it because it's not much controllable, the operating system inside.
Yeah.
Yeah.
Do you have plans to give enterprise control of that operating system?
I have lots of ideas about it.
But first of all, can I say, our role is Linux in Azure, so the scope of what we were looking to do here was Linux in Azure specifically. WSL is
Completely different.
Yeah, what we're doing on the desktop with applications with WSL is we could do a whole other talk on that.
Yeah, but in trying not to like ship the org chart and the different offerings, it is a completely different team, and we interact pretty regularly. There's even, it's a common internal request as well to be able to have things like an immutable read-only OS, something that could have integrity and boot up, and you could actually control it or prescribe like the distro that gets installed and stuff like that. And we have collaborated on like ideas about it, and any kind of ETA or developments, I have no idea because it is a different team, but it's something we're interested in, but we look forward to as well. WSL team is absolutely, 𝗦𝗲𝘀𝘀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 some talks, and I'm sure is at some of the booths.
And we
So
did just announce support for RHEL in WSL and some new packaging formats as well.
Yeah, so we're right at time. Maybe if it's quick, or they might pull us off.
Real quick, do you think there'll ever be a Linux flavor of Azure Local?
Yes, I can catch up with you, but yeah, so the Azure Linux that they've announced for what was Azure HCI or Azure Local now is deployed with Azure Linux on it, but the big thing is obviously validating it for different hardware use cases. So, yeah. But yeah, absolutely, I've heard it's coming. All right, so thank you, everybody.
Thank you.
Come up.